Hello friends, now in this video we will see indefinite integration in one shot. I will cover exercise 3.1, exercise 3.2a, 3.2b, 3.2c, 3.3 and 3.4. I will give link of all these videos in description box. Now in this video I will explain all types of examples which asked in previous example in a very simple language. Now let us start. What's the indefinite integration? Now the multiple choice questions. Here the first question. Integral of 1 upon x into log of x dx. This question asked in March 13. Okay. First option A is a log of x plus c. Second B 1 upon 2 log of x bracket square plus c. Third 2 log of x plus c. D log of x plus c. Now let us see the solution of this. Okay. Now here we will solve this example with the method of substitution. Put log of x is equals to t, and after differentiating you will get here, that is the differentiate this with respect to x. What is the derivative of log of x is 1 upon x into dx, and the derivative of t is a dt. Therefore the value of 1 upon x into dx is dt. Therefore here is the 1 upon x into dx, its value is dt, and the log of x is t. Therefore we will find out here integral of t into dt, because instead of 1 upon x into dx is nothing but the dt, and the log of x is t. Now here the integral of t is a t square upon 2 plus c. Resubstitute the value of t, then you will get here 1 upon 2 log of x bracket square plus c, and hence here the option B is correct here. Now next example. Integral 1 upon 1 plus cos of x dx. Okay, and the options are tan of x by 2 plus c. B option is a 2 times tan of x by 2 plus c. C is a minus cot of x by 2 plus c, and the d is a minus 2 cot of x by 2 plus c. Now we will solve this example. Now first of all here, what is the formula? That is a 1 plus, here is a cos of x. What is that formula? That is a 2 times cos square x by 2. Okay, and using this formula we will solve this example. See this here, that is integral 1 upon 1 plus cos of x dx is equals to integral 1 upon 2 cos square x by 2 dx. Now the 1 upon cos square x by 2 means what? Sec square x by 2, and the integral of sec square is a tan of x by 2 upon derivative of this x by 2. Derivative of x is 1 upon 2 plus c, and after simplification you will get here tan of x by 2 plus c, and hence option A is a correct here. Next example. Integral dx upon 9x square plus 1. Okay, now the first option here A is a 1 by 3 tan inverse of 2x plus c. B is 1 by 3 tan inverse of x plus c. C is 1 by 3 tan inverse of 3x plus c, and D is 1 by 3 tan inverse of 6x plus c. Okay, now here we will apply the standard result of the tan inverse. What is that result? That is a integral of 1 upon x square plus a square, and that is equals to 1 upon a tan inverse of x upon a plus c. And first of all here, see this is the answer here, that integral dx upon 9x square plus 1 is equals to integral dx upon 9x square is a square of 3x bracket square plus 1 square. Okay, therefore its integral is a 1 by 3 tan inverse of 3x plus c. Okay. And here we will also have one more result, that is the integral, here is a dx, okay, dx upon, if I write here a x and bracket square plus b square, then what about its integral? Its integral is a 1 upon ab, and here is a tan inverse of, okay, tan inverse of ax upon b and plus c. Now here the value of a is a 3 and the value of b is a 1. Therefore 3 into 1, that is nothing but the 3. Okay, therefore the 1 by 3 tan inverse of 3x plus c, and hence option C is a correct here. Now next, integral of x plus 3 upon x plus 4 bracket square into e raised to x into dx is equals to. Okay, now to solve this example, we'll apply here this type of the arrangement. Now arrange here numerator just like as a denominator. Therefore integral e raised to x plus 3 can be written as x plus 4 minus 1 upon x plus 4 bracket square. Now split up this, means what? X plus 4 upon x plus 4 bracket square. Then x plus 4 will get cancelled. You will get here 1 upon x plus 4 minus 1 upon x plus 4 bracket square. Now this is of the form. Which is the form? Integral e raised to x in bracket f of x plus f dash of x bracket complete into dx. And that's equals to e raised to x into f of x plus c. Now what is the value of here f of x? The value of f of x is a 1 upon x plus 4, and hence answer is e raised to x upon x plus 4 plus c. Now which option is the correct here? The option C is correct here. Okay. Next example. If integral dx upon 4x square minus 1 is equals to a log of in bracket 2x minus 1 upon 2x plus 1 bracket complete plus c, then what is the value of a? Option A is 1, B is 1 upon 2, C is 1 by 3, and D is 1 by 4. Now let us solve this example. Now integral dx upon 4x square minus 1 is equals to, now 4x square is a square of 2x bracket square minus 1 square. Now this is of the form, the integral, it is just like that is a dx, here is a x square minus a square, and that is equals to 1 upon 2a, and here is a log of a mod of that is a x minus a upon x plus a plus c. But here the 2x, and therefore we will change here. This integral is just like here is a x bracket square minus b square, and it is this is nothing but 1 upon 2 a b, and here is a log of mod of that is a ax minus b upon ax plus b mod complete and plus c. Okay, and hence the option here is the value of a. If we compare this, that is a into log of 2x minus 1 upon 2x plus 1. If we compare this, the value of a is 1 by 4, and hence option D is correct here. Now next, number 6, integral cos cube x dx. Okay, and here the options are, first option A is 1 upon 12 sine of 3x plus 3 by 4 sine x plus c. B is 1 upon 12 sine of 3x plus 1 by 4 sine x plus c. C is 1 upon 12 sine of 3x minus 3 by 4 sine x plus c. And D is 1 upon 12 sine of 3x minus 1 by 4 sine x plus c. Now here you must know the formula of cos cube x. Okay. Now what is the formula for the cos cube x? The cos cube x is the formula for the, that is cos cube x is equals to, here I will write here 1 by 4 cos of 3x 3 cos of x bracket complete. Okay, and here we have substituted the value of cos cube x. Okay, now take 1 by 4 outside here. What is the integral of cos of 3x? Integral of cos of 3x is the sine of 3x upon derivative of 3x is a 3 here, and the integral of this cos of x is a sin x, that is a 3 into sin x bracket complete. Okay, And therefore, after simplification, you will get here sine of 3x upon 4 into 3. Then you will get here 12, okay, plus that is a 3 by 4 sine x plus c. And hence, if we see this here, that is a sine of 3x upon 12, sine of 3x upon 12, 3 by 4 sine x plus c. And hence here, the option A is correct here. Okay. Now, in this way, we have completed all the multiple choice questions. Now, next, we'll see the question based on exercise 3.1. Now, exercise 3.1. I will also give you the link of exercise 3.1 in description box. Okay. If f dash of x is equals to k in bracket cos of x minus sin of x, and the value of f dash of 0 is equals to 3, and f of pi by 2 is equals to 15, find the function f of x. Okay. Now here we first find the value of f of x. We have given the f dash of x, but therefore the f of x is nothing but the integral of f dash of x. That is integral of k, the value of f of x, that is cos of x minus sin of x. That is k into cos of x minus sin of x. That is k is a constant. Therefore, integrate cos of x minus sin of x. Integral of cos of x is sin of x, and the minus sin of x is minus cos of x, and that's minus minus will make plus. Okay, therefore we have the function which is the f of x is equals to k sin of x plus cos of x plus c. Now we will find the value of f of pi by 2, that's equals to 15. Now substitute here the value of x as a pi by 2. See this here. First is f dash of 0 is equals to 3. Okay. Now substitute the value here. Okay. K into cos of 0 minus sin of 0. Now here, this is the f dash of x is equals to k cos of x minus sin of x. Now replace here the x by 0. We have to replace its a value x by 0, k into cos of 0 minus sin 0, and its value is a 3. Now what is the cos 0? Cos 0 is 1, sin 0 is 0. Therefore k into 1 is a k is equals to 3. Okay, therefore the value of k is a 3. Okay, this is the second one. And this is the first one. Okay. This is the first one. Now next, also f of pi by 2 is equals to 15. But what is the function? Function is f of x is equals to k sin x plus cos x. Now replace here x by pi by 2. Now we know the value of cos of pi by 2 is a 0. Sin of pi by 2 is 1. Therefore k into 1 plus, means k plus c is equals to 15. And therefore after simplification, here you will get the, we have substituted here the value of k as a 3. Okay, 1 plus 0 is a 1, 3 into 1 is 3, 3 plus c is equals to 15. Therefore c is equals to 15 minus 3, and that is equals to 12. Now substitute the value of c and k in equation number 1. Then you will get the function f of x. Therefore putting the values of second and 3 in 1. Therefore you will get here f of x is equals to 3 in bracket sin x plus cos x plus 12. Okay, this way we have completed this. Next example, if f dash of x is equals to x raised to minus 1, then find f of x, asked in March 22. Now what is f of x? F of x is equals to integral of f dash of x dx. Okay, and that's equals to, now substitute the value of f dash of x, that is x raised to minus 1. X raised to minus 1 means what? 1 upon x. That is the integral of 1 upon x dx. Now what is the integral of 1 upon x? Is the log of x. Therefore f of x is equals to log of x plus c, and this is the answer. Okay, next, based on exercise 3.2a, I will give you the link of this video, that is exercise 3.2a, in description box. These are the examples which asked in board examination. Now let us see. First example, if x is equals to phi of t is a differentiable function of t, then prove that integral of f of x dx is equals to integral of f of phi of t into phi dash of t into dt. And this is the theory type question. Okay. Now proof. Let x is equals to phi of t. Then what is it? It's a derivative. That is a differentiate this with respect to t. Therefore, dx upon dt is equals to phi dash of t. Put integral f of x dx is equals to g of x. And the derivative of g of x is f of x. Okay. Consider derivative of g of x with respect to t is equals to ddx of g of x into dx upon dt with the help of the chain rule. Okay. Therefore, what is the derivative of g of x? Derivative of g of x is here f of x into dx upon dt. Now substitute the values here. That is the value of x. Therefore, here f of phi of t. And what is the dx upon dt? Dx upon dt is a phi dash of t. Here we have substituted the value. Okay. Now, therefore, by definition of integration, you will have here, that is a g of x is equals to, okay, g of x is equals to integral of f of phi of t into phi dash of t into dt, and hence integral of f of x dx is equals to, but what is the g of x here? G of x is nothing but the integral of f of x is equals to integral of f of phi of t bracket complete into phi dash of t into dt. Okay, we have proved this. Now next example, evaluate integral sec of x raised to n into tan of x dx, which asked in March 14 examination. Now let I is equals to, this can be written as, I will repeat here, let I is equals to integral sec of x raised to n into tan of x dx. Now we will solve this example with the help of method of substitution. We know the derivative of sec of x is sec x into tan x, and hence here we will write here, that is a sec raised to n can be written as sec of x raised to n minus 1 x into sec of x into tan of x dx. So that we will substitute here sec of x as a t, and its a derivative is a sec x into tan x, and here put sec x is equals to t, and its derivative is that is a differentiate this with respect to x. Derivative of sec of x is a sec x into tan x into dx is equals to dt, so that the value of sec x into tan x dx is nothing but dt, and hence here I is equals to integral t raised to n minus 1 dt. Now what is the integral of x raised to n? X raised to n is the integral of x raised to n is x raised to n plus 1 upon n plus 1. Similarly here, integral of t raised to n minus 1 is a t raised to n minus 1 plus 1 upon n minus 1 plus 1 plus c. Now plus 1 minus 1 get cancelled, and hence finally you will get here t raised to n upon n plus c. Now resubstitute the value of t. What's the value of t? The value of t is a sec x. Therefore I is equals to sec x raised to n upon n plus c, and this is answer. Now next example. Evaluate integral 1 upon x log of x into log of x dx. Okay, asked in October in examination. Now here we also apply the method of substitution. Now here the derivative of log x is x into 1 upon x into log of x. Therefore for this we'll substitute here log of x as a t. See this here, log of x is a t, therefore differentiating with respect to x. What is the derivative of log x? Then the first is 1 upon log x into derivative of this log of x, which is 1 upon x into dx, and that's equals to dt. And overall you will get here the 1 upon log of x into dx, its a value is a dt. If we substitute here, that is the 1 upon x a log of x, it's a value as a dt, and the next is a log x as a t. This is the t. Okay. Therefore, what is the integral of 1 upon t? Integral of 1 upon t is a log of mod of t plus c. Now, resubstitute the value of t. Okay. Substituting the value of t. Then you will get here I is equals to log of log mod of log x mod complete plus c. And this is the its integration. We apply here the method of substitution. Okay. Now, next example. Evaluate integral sine of root x upon root x into dx, asked in March 17 examination. Now, this example is also depends on the method of substitution. We know the derivative of root x is 1 upon 2 times root x, and we apply here the method of substitution. Root x is equals to differentiating with respect to x, you will get here 1 upon 2 root x dx is equals to dt. But we require here only 1 dx upon root x. Therefore, the value of dx upon root x is a 2 dt. Okay. We write here 2 dt. Now, substitute the value of I is equals to integral sine of t into 2 dt. Now, next, let the 2 has a constant integral sine of t into dt. That's nothing but the minus cos t plus c. Resubstitute the value of t, which is the root x. Okay. Therefore, I is equals to minus 2 cos of root x plus c. And this is the answer. Now, next example. Evaluate integral root of tan x upon sin x into cos x dx. Okay. This example asked in July 17 examination. Okay. Now here, first we here arrange the term, that is here divide numerator and the denominator by cos square x. That is the root of tan x upon cos square. This whole divided by sin x into cos x upon cos square. But what is here? First of all, root of tan x upon cos square, the reciprocal of that is here 1 upon cos square is a sec square x. Okay, into root of tan x. Now here 1 cos will get cancelled. You will get here sin x upon cos x, and that is nothing but the tan x. Okay. Now here the next is a integral. This is the sec square root of tan x upon tan x. Then that root will get cancelled, and to the denominator you will get here a root of tan x. Now what is the substitution here? If we see here, the derivative of tan x is the sec square x, and hence here the substitution is a tan of x is equals to t. Okay. Now let's solve this example, and it's a derivative. That is a derivative of tan of x is a sec square x into dx is equals to dt. Therefore, the value of sec square x into dx has a dt, and to the denominator a root t. We'll take here to the numerator, and its power will become minus. Again, very simple integration. That is a x raised to n integral is a x raised to n plus 1 upon n plus 1. Similarly here, minus 1 by 2 plus 1 means what? T raised to 1 upon 2 upon 1 upon 2 plus c. Now, after simplification, that is, you will get here I is equals to 2 root t plus c. Resubstitute a value of t, which is the tan x, and hence I is equals to 2 root of tan x plus c, and this is the answer. Okay. Now, next example. Evaluate integral 1 upon sin x into cos square x, asked in July 18 examination. Very simple example. I is equals to integral 1 upon sin x into cos square x. Now here, we'll change here. This is the 1 means what? Sin square x plus cos square x upon sin x into cos square x. Now split up this. Okay. Means you will get here, that is a sin square x upon sin x into cos x. One sin will get cancelled. You will get here integral sin of x upon cos square x dx plus, that is a cos square x upon sin x into cos square x. Cos square will get cancelled. You will get here integral 1 upon sin x. Okay. Now next arrangement is like this. Sin x upon cos x is a tan x, and 1 upon cos x means what? Sec x. Now see this here. This can be written as sin x upon cos x into 1 upon cos x into dx plus integral 1 upon sin x means what? Cosec x. That is sin x upon cos x is a tan x into sec x. Therefore, integral of tan x into sec x plus integral of cosec x. Now here the integral of tan x into sec x is sec x, and the integral of cosec x is log of tan of x by 2 plus c. Okay, and this way I have completed this exam. Now next example, evaluate integral e raised to x in bracket 1 plus x upon cos square in bracket x into e dx. Okay, this example asked in March 19 examination. Now here the method of substitution. This example depends on the method of substitution. What is here? X into e raised to x is equals to t. Therefore, see this here, x into e raised to x is equals to t. Differentiate this with respect to x, then you will get here by using with the help of the product rule. That is the first x as it is, derivative of e raised to x is e raised to x plus e raised to x into derivative of x is 1, bracket complete into dx is equals to dt. And here, if you take e raised to x as a common, then in bracket you will get here 1 plus x bracket complete into dx. Okay, and that's equals to dt. Now our integral becomes I is equals to integral. The value of e raised to x in bracket 1 plus x dx is the dt. Okay, and here integral 1 upon cos square t. Okay, again here cancel here one more sign of the integration. Okay, therefore integral of the 1 upon cos square t means what? Sec square t, and the integral of sec square t is a tan t plus c. Resubstitute the value of t here. Okay, that is the value of t is a x into e raised to x. Okay, therefore I is equals to tan of in bracket x into e raised to x plus c. This is the answer. Next example. Solve that is integral x raised to x into in bracket 1 plus log of x dx. Okay, this example asked in July 19 examination. Now here I is equals to integral x raised to x into in bracket 1 plus log of x bracket complete into dx. Now here put x raised to x is equals to t. Okay, and differentiating this with respect to x, then you will get here it's a differentiation, that is x raised to x in bracket 1 plus log of x into dx is equals to dt. For this differentiation, we here apply the taking the log on both sides. Then what is here? If you take log on both sides, that is a log of log x is equals to here the log of t. Now differentiate this. We differentiate this with respect to x. Then the first, the derivative of log of x is a 1 upon x plus, okay, derivative of x is a 1. That is a 1 into here log of x. And the derivative of t is a 1 upon t. Log of t is a 1 upon t into dt. Here x will get cancelled. You will get here 1 plus log of x bracket complete this whole into dt dx. Okay, this whole into dx, that is a 1 upon t into dt. Therefore, the value of here t is a x raised to x. If you take here to the left hand side, then it will become that the t in bracket 1 plus log of x into dx is equals to dt. Resubstitute the value of t, that is the x raised to x in bracket 1 plus log of x bracket complete into dx is equals to dt. This is the value of x raised to x into in bracket 1 plus log of x, and that is the dt. Therefore, here the integral is only integral of dt. That is a 1 dt, and the integral of 1 dt is a t. Okay, t plus c. Therefore, resubstitute the value of t, which is the x raised to x plus c, and hence this is the answer. Next example. Solve integral 10 into x raised to 9 plus 10 raised to x into log of 10 upon 10 raised to x plus x raised to 10. Now, if you observe here, that is a substitution. That is that if we take the substitution 10 raised to x plus x raised to 10 as a t, then we can solve this example easily with the help of method of substitution. Put here x raised to 10 plus 10 raised to x is equals to t. After differentiating, you will get here the derivative of 10 raised to x raised to 10 is a 10 into x raised to 9. And the derivative of 10 raised to x is a 10 raised to x into log of 10 bracket complete into dx is equals to dt. Okay. And this is the value of 10 into x raised to 9 plus 10 raised to x into log of 10. Its a value is a dt. Therefore, I is equals to integral dt upon t. And its integral is a log of mod of t plus c. Now resubstitute the value of t. What is the value of t? That is x raised to 10 plus 10 raised to x. Okay. And hence this is the answer. That is I is equals to log of mod of x raised to 10 plus 10 raised to x mod complete plus c. Now next example. Solve that is a 2 sin x plus 3 cos x upon 3 sin x plus 4 cos x into dx. This example asked in July 19 examination. Now this example is a very special one. Arrange here the numerator in a very special manner. Okay. Now see this here 2 sin x plus 3 cos x is written as a into 3 sin x plus 4 cos x is a denominator plus b into derivative of that is a 3 sin x plus 4 cos x, that is a it can be written as that is a 2 times sin x plus 3 cos x is equals to a into here d means what denominator plus b into derivative of the denominator. This numerator can be written as that is a numerator is equals to n is equals to a into d. Okay, now you can see this here. If I write here numerator n is equals to a into d plus b into ddx of denominator. Okay, now see this here. The first is a into 3 sin x, a into 4 cos x. Then you will get here 3a sin x plus 4a cos x. Next is the derivative of sin x is a cos x, derivative of cos x is a minus sin x. Now collect the terms of sin x and the cos x. That is 3a sin x plus 4a cos x plus 3b cos x minus 4b sin x. Collect the terms of sin x and the cos x. Then you will get here 3a minus 4b bracket complete into sin x plus 4a plus 3b bracket complete into cos x. Therefore, we have arranged this numerator like this. Okay. Now compare the coefficient of sin x. Here the coefficient of sin x is a 3a minus 4b, and to the left hand side the coefficient of sin x is 2. Therefore, you will get here the first equation, that is a 3a minus 4b is equals to 2. What is the coefficient of this cos x? The coefficient of this cos x is a 4a plus 3b, and here the coefficient of cos x is a 3. Therefore, you will get here by equating the coefficient of both sides, then you will get here these are the two equations. 3a minus 4b is equals to 2 and the 4b plus 3b is equals to 3. And solving these two equations, you will get the value of a and b. Now see this here, the value of a and b here. Solving this value, you will get here the value of a is 18 upon 25 and b is 1 upon 25. Now substitute the value of these a and b. That is this numerator 2 sin x plus 3 cos x is equals to 18 upon 25 in bracket 3 sin x plus 4 cos x plus b. The value of b is 1 upon 25. 3 cos x minus 4 sin x. Okay. And hence you will get here the finally here the arrangement. This divided by the denominator. Now split up this 3 sin x plus 4 cos x get cancelled here. Then you will get here 18 upon 25 integral 1 dx plus 1 upon 25 3 cos x minus 4 sin x upon 3 sin x plus 4 cos x dx. If we observe here, this is the f dash of x and this is f of x. Now the integration is very easy. 18 upon 25 integral of dx is x plus 1 upon 25. Here you will get here log of mod of 3 sin x plus 4 cos of x plus c. Here we apply the formula integral f dash of x upon f of x dx is equals to log of mod of f of x plus c. Now that arrangement is very important. That is the numerator is equals to a into denominator plus b into derivative of the denominator. And this is the answer. Now next example, evaluate the integral x square into tan inverse of x cube upon 1 plus x raised to x into dx. This example asked in February 20 examination. Now here again the substitution. Okay. Put here tan inverse of x cube is equals to t. Then differentiate this with respect to x. Then you will get here 1 upon 1 plus x raised to 3 bracket square into derivative of x cube is a 3x square into dx is equals to dt. And after simplification, you will get here x square upon 1 plus x raised to 6. X cube bracket square means what x raised to 6 into dx is equals to dt upon 3. Here we have the value of x square upon 1 plus x raised to 8 into dx is nothing but dt upon 3. Now substitute the value. Then you will get here I is equals to integral t into dt upon 3. Take 1 by 3 as outside this integration. Then integral of t into dt is nothing but t square upon 2. Okay. That is the 1 by 3 dot t square upon 2 plus c. This substitute the value of t. Okay. That is the 2 into 3 means what 6. And therefore you will get here the value of t is a tan inverse of x cube. And it's a bracket square plus c. And hence this is answer. Now next example. Evaluate integral 1 upon x log x into dx. This example asked in July 22 examination. It's very simple example with the help of method of substitution. That is a put log of x is equals to t. Then you will get here the derivative of log of x is 1 upon x. And here is the function. That is the integral f dash of x upon f of x. That is equals to log of mod of f of x plus c. Here the function is a log of x. It's a derivative number x. Therefore the integration is I is equals to log of x plus c. Next example. Now we write the integral of cot of x into dx. Very simple example with the help of method of substitution. I is equals to cot of x into dx. Now this cot of x can be written as cos of x upon sin of x. If we observe here, the derivative of sin of x is a cos of x. Again, with the help of the same formula, here the integral f dash of x upon f of x is equals to log of f of x plus c. And here I is equals to log of mod of sin of x plus c. And this is the answer. Now next example. Evaluate integral 1 upon x in root of log of x dx. This example asked in July 23 examination. Okay. Now here let I is equals to integral 1 upon x in root of log of x dx. Now substitute here. Log of x is equals to t square. Therefore the derivative of log of x is 1 upon x dx is equals to 2t into dt. Now the value of 1 upon x dx is a 2t into dt upon root of t square. That is the value of log of x is the root of t square. Log of x is a t square. Therefore its root is a t. Okay. Then dt will get cancelled. You will get here 2 integral dt, 1 dt. That is the integral of 1 is a t. Therefore you will get here the answer 2t plus c. Okay. Then substitute the value of t here. That is a I is equals to, what is the value of t? Root of log x. Therefore I is equals to 2 root of log x plus c, and this is the answer. Now next example, evaluate integral 3 raised to x minus 4 raised to x upon 5 raised to x into dx. This example asked in July 23 examination. Now see this here. Let I is equals to integral 3 raised to x minus 4 raised to x upon 5 raised to x. Split up this. That is integral 3 upon 5 whole raised to x minus 4 by 5 whole raised to x into dx. Now the integral of a raised to x. Integral of a raised to x is the a raised to x upon log of a. And similarly here, the integral of 3 by 5 raised to x is a 3 by 5 raised to x upon log of 3 by 5. Just cancel here x. Okay. Minus 4 by 5 bracket raised to x upon log of 4 by 5 plus c. Okay. And this is the answer. Now next example, integral of e raised to x upon 1 plus e raised to minus x into dx. This example asked in July 23 examination. Now here multiplied numerator and the denominator by e raised to x. Okay. Then you will get here, that is a I is equals to e raised to x into e raised to x. If you multiplied 1 into e raised to x, then you will get here, that is a e raised to x, and the e raised to minus x into e raised to minus x. Then you will get here e raised to minus x into e raised to x. Then you will get here e raised to 0 is 1. Therefore here first if we multiply here e raised to minus x by e raised to x, then you will get here 1. And if you multiply this 1 by e raised to x, then you will get here e raised to x. Overall, you will get here to the numerator e raised to x, okay, into e raised to x upon 1 plus e raised to x into dx. Now put here e raised to x as a t. We solve this example with the help of method of substitution. What is the proper substitution here? E raised to x is equals to t. It's a derivative. E raised to x into dx is equals to dt. Therefore, I is equals to integral e raised to x into dx, again is a t. So value is a dt. Therefore, integral this t into dt upon 1 plus t. Now split up this. It can be written as like this integral. This numerator can be written as just like as the denominator. Means what? T can be written as 1 plus t minus 1. Add in here plus 1 minus 1. Split up this. Then you will get your integral t plus 1 upon 1. Sorry, 1 plus t upon 1 plus t. Get cancelled, you will get here 1. Minus 1 upon 1 plus t. Now integrate this. The integral of t, integral of 1 is a t. And the integral of 1 upon 1 plus t is a log of mod of 1 plus t plus c. And this is the answer. Please substitute the value of t, which is e raised to x. Therefore, I is equals to e raised to x minus log of mod of 1 plus e raised to x plus c. And this is the answer. Now, in this way, we have completed that exercise. The link of that video will give in the description box. And similarly, now we'll start the example which asked in board examination based on exercise 3.2b. I will also give the link of this video in the description box. You can see that. Okay. Now first example, evaluate integral 1 upon 3 plus 5 cos x dx. This example asked in March 13 examination. Now to solve this type of examination, take the substitution, that is a put tan of x by 2 is equals to t. Okay. Therefore, you will get here x is equals to, that is a 2 times tan inverse of t. Now it's a derivative. That is a 2. Derivative of tan inverse of t is a 1 upon 1 plus t square. Therefore, dx is equals to 2 dt upon 1 plus t square. And what is the value of cos of x? The value of cos of x is a 1 minus t square upon 1 plus t square, and the value of sin of x is also there. Okay. Now here we required only the value of cos of x. Substitute the value of ax, that is a 2 dt upon 1 plus t square, 2 dt upon 1 plus t square, 1, that is a 3 plus 5. Value of, that is the formula for the cos of x in terms of the t. 1 minus t square upon 1 plus t square. Now after simplification, You will get here 1 plus t square into 3, this whole divided by 1 plus t square. The denominator 1 plus t square, 1 plus t square get cancel, and you will get here that is a 2 integral dt upon that is a 3 plus 3t square plus 5 minus 5t square. And after simplification, you will get a 2 integral dt upon 8 minus 2t square. Okay. Now here the take that is a 2 as a common. That is a 2 upon 2. That 2 get cancelled. Then you will get your integral dt upon 2 raised to 2 minus t square. And it is of the form integral that is a dx upon a square minus x square. And it is nothing but 1 upon 2a log of 2 plus t in mod of 2 plus t upon 2 minus t plus c. Now resubstitute the value of t, which is the tan of x by 2. Okay. And therefore you will get here 1 by 4 log of mod of 2 plus tan of x by 2 upon 2 minus tan of x by 2 plus c. And this is the answer. Okay. Now next example. Show that integral 1 upon x square in root of a square plus x square into dx is equals to minus 1 upon a square in root of a square plus x square upon x plus c. This example asked in October 15 examination. Now solve this. I is equals to integral 1 upon x square in root of a square plus x square dx. Now put x is equals to a tan theta, and after differentiation you will get here, okay, that is a dx is equals to a derivative of tan of theta is a sec square theta into theta. This is the value of dx. Now substitute the value, that is x is equals to a tan theta in this equation. That is in this integral, I is equals to integral a. The value of dx is a sec square theta into d theta, and the value of x square is a square tan square theta in root of a square plus a square tan square theta. Take a square as a common. 1 plus tan square theta is a sec square theta, and root of sec square is again the sec theta. Now see this here simplification. 1 upon a sec square theta into d theta. Okay. That is a tan square theta in root of a square sec square theta. 1 upon a integral sec square theta tan square theta. Okay. And if we take it's a root, then you will get here a sec theta. Okay. And next here, see this here 1 upon a square sec theta upon tan square theta into d theta. That is a 1 upon a integral. Now again, what is meant by tan square? Tan square is nothing but sin square theta upon cos square theta. And then you will get here 1 upon tan square is nothing but the cos square theta upon sin square theta. Sec means what? 1 upon cos. Okay. Therefore, you will get here 1 upon a square integral. Now here 1 cos will get cancelled, integral cos theta upon sin square theta. But what is a, this can be again written as, that is a 1 upon sin square can be written as 1 upon sin theta into cos theta upon sin theta. Therefore 1 upon a square integral 1 upon sin theta into cos theta upon sin theta, and this is nothing but 1 upon a square integral cosec theta into cot theta d theta, and its integral is minus cosec theta plus c. Okay. Now this substitute the value. Okay. That is, you will get here the tan of theta is equals to x upon a, that is the cot theta is equals to a upon x. Okay. Therefore the cosec theta is nothing but in root of 1 plus cot square theta, and that is nothing but in root of 1 plus a square upon x square. And after simplification, that is 1 into x square plus a square upon x square. The root of x square is x. Therefore, you will get here in root of x square plus a square upon x. Okay. And therefore, integral of 1 upon x square in root of a square plus x square dx is minus 1 upon a square into the value of cosec theta. What is that? The value of cosec theta in root of x square plus a square upon x plus c. And this is the answer. Okay. Now next. Evaluate integral sine theta upon in root of 36 minus cos square theta dx. This example asked in March 16 examination. What's your substitution? That is the cos of x is equals to t. Okay. See this here. Let I is equals to integral sin x upon in root of 36 minus cos square x into dx. Put here cos x is equals to t. Differentiating with respect to x. Then you will get here derivative of cos of x is a minus sin of x dx. Derivative of t is a dt. We have here the value of sin of x into dx is equals to minus dt. Okay, and therefore here integral become I is equals to minus integral, that is a 1 upon in root of 6 square minus t square into dt. And this is the integral of this is nothing but sin inverse of t upon 6 plus c. Now again resubstitute the value of t. Okay, therefore I is equals to minus sin inverse of in bracket cos of x upon 6 plus c. And this will be answer. Next example. Evaluate integral 1 upon 3 plus 2 sin x plus cos x into dx. This example asked in July 16 and March 18 examination. Now here again the substitution here, tan of x by 2 is equals to t. X is equals to 2 tan inverse of t. Therefore dx is equals to 2 dt upon 1 plus t square. The value of sin x and cos x will be required here in terms of t. What is the value of sin x? Sin x is equals to 2t upon 1 plus t square. Cos x is equals to 1 minus t square upon 1 plus t square. Okay. Therefore, I is equals to integral 1 upon. That is a substitute the values. Okay. The value of dx is a 2 upon 1 plus t square into dt. Substitute the value of sin x and cos x. And after simplification, you will get here 2 dt. And the denominator of the 1 plus t square of this 1 upon t square get cancelled. That is a 3 into 1 plus t square. Then you will get here 3 plus 3t square. Next, again 2 into 2t. That is a 4t. And the 1 plus t square again get cancelled. You will get here 1 minus t square. And after simplification, you will get here. Now see this here. After simplification, what is here? 3t square minus t square. You will get here 2t square, 4t, and the 3 plus 1. That is a 4. Now take 2 as a common, that is a 2 upon 2 integral dt upon t square plus 2t plus 2. 2 to get cancelled, integral dt upon t square plus 2t plus 2. And now arrange in a perfect square. That is 1 upon 2 coefficient of t bracket square is equals to, okay, is equals to 1 upon 2. What is the coefficient of t is 2. 2 to get cancelled, you will get here 1. Therefore add plus 1 and the minus 1. Then this denominator will become perfect square. Therefore, integral dt upon t square plus 2t plus 1 minus 1 plus 2. Okay. But this is the perfect square of t plus 1 bracket square plus 1 square. Okay. Now, the integral of this is very simple. It's of the form integral. That is a dx upon x square plus s square. That is a 1 upon a tan inverse of x upon a. Therefore, tan inverse of t plus 1 upon 1 plus c. Now, resubstitute the value of t. What is the value of t? Tan of x by 2. Okay. Plus 1 plus c. Okay. Tan inverse of tan of x by 2 plus 1 plus tan of x by 2 plus 1 bracket complete plus c. Okay. This is the answer. Now, next example. Prove that dx upon in root of x square plus x square is equals to log of mod of x plus in root of x square plus x square plus c. Again, here's the substitution. X is equals to a tan theta. Then what is the tan theta? X upon a. That's it's a derivative. The derivative of dx, that is the x is a dx. Derivative of tan theta is a sec square theta into d theta. Therefore, our integral becomes integral dx upon in root of x square plus x square. The value of dx is a sec square theta into d theta. Substitute the value of x. That is a square tan square theta plus x square. A square as a common. Tan square theta plus 1 is a sec square theta. Root of sec square is a sec theta. 1 sec will get cancelled. You will get your integral a sec square theta upon a sec theta d theta. A get cancelled, integral sec theta into d theta. But what is the integral of sec theta? Is the log of mod of sec theta plus tan theta plus C1. Okay. Now next, this is the sec theta is nothing but in root of sec square theta. Tan theta is nothing but x upon a. Therefore, I is, that is a the integral will become, that is a log of in root of sec square means what? 1 plus tan square theta plus x upon a. Again, just substitute the value of this tan theta, which is the x upon a. Okay, now see this here. We will substitute the value of here, that is a log of in root of 1 plus x square upon x square plus x upon a. Then you will get here, that is a log of mod of in root of 1 plus x square upon a square plus x upon a plus c1, and the after the simplification, that is a square plus x square upon a plus x upon a, then we can add it, that is a log of in root of x square plus a square plus x upon a, okay, plus c1, and there is a one more. This is the log of m upon n, means what? Log of in root of x square plus a square plus x minus this log of a plus c1. Now we'll take one more constant here. This is nothing but constant is nothing but c. Okay. Therefore, integral dx upon in root of x square plus a square is equals to log of in mod of in root of x square plus a square plus x plus c. And this is the answer, where the c is equals to minus log of a plus c1. Okay. Now next, evaluate integral dx upon x square plus 4x plus 8. This example asked in February 20 examination. It's very simple solution. Let I is equals to integral dx upon x square plus 4x plus 8. Now what about the last term? That is 1 upon 2 coefficient of x bracket square is equals to 1 upon 2 coefficient of x is 4 bracket square. Then you will get here 2 bracket square. Okay, that's equals to 4. Therefore, the second term is 4, means what? X square plus 4x plus 4 to make the perfect square. Therefore, we will add here plus 4 and the minus 4. See this here. I is equals to integral dx upon x square plus 4x plus 4 minus 4 plus 8. Now, this is the perfect square of x plus 2 bracket square minus 4 plus 8 is nothing but 4. 4 means what? 2 square. And again, this is of the form tan inverse. Okay. Therefore, here I is equals to integral. That is 1 upon 2 tan inverse of. This is the integral of the form dx upon x square plus x square. Its integral is a 1 upon a tan inverse of x upon a plus c. Similarly, here the value of a is therefore 1 upon a tan inverse of x is x plus 2 upon a means or 2 plus c. And hence, this is the answer. It's very simple example to make the perfect square. We find out the second term, which is the 4. Okay. Now, next example. Evaluate integral dx upon 2 plus cos x minus sin x. March 22 examination. Again, here the what is substitution? Again, tan of x by 2 is equals to t. Value of cos x and the sin x in terms of the t. Put tan of x by 2 is equals to t. Differentiate. That is x is equals to 2 tan inverse of t. Dx is equals to 2 dt upon 1 plus t square. The value of sin x in terms of t is at 2t upon 1 plus t square. Cos x is 1 minus t square upon 1 plus t square. Okay. What about the next? I is equals to integral. Substitute the value. That is a 2. The value of cos x, sin x, the value of dx. That is a 2 dt upon 1 plus t square. And after simplification, 1 plus t square, 1 plus t square get cancelled. That is a 2 into in bracket 1 plus t square means what? 2 plus 2t square, 1 minus t square minus 2t. And overall, that is a 2 integral 1 upon t square minus 2t plus 3 dt. Now make again the perfect square. Okay. Now again the formula, that is 1 upon 2 coefficient of t bracket square. 1 upon 2 coefficient of t is a minus 2. Okay, 2 get cancelled, you will get a minus 1. minus 1 square is a plus 1. Therefore, to make the perfect square, add plus 1 and the minus 1. That is 2 times integral 1 upon t square minus 2t plus 1 minus 1, and there is a 3. Okay. And after simplification, minus 1 plus 3, you will get here 2. Okay. Therefore, 2 integral, now this t square minus 2t plus 1. It's a perfect square of t minus 1 bracket square. Now again, it is of the form tan inverse. Okay. That integral dx upon x square plus s square into dx is 1 upon a tan inverse of x upon a plus c. Similarly here, that is a 2 means what? Root 2 bracket square. Therefore 2, 1 upon a means what? Here root 2 tan inverse of t minus 1 upon root 2 plus c. Resubstitute the value of t, which is the tan of x by 2. Okay. And this is the answer. Now next, prove that integral 1 upon x square minus x square dx is equals to 1 upon 2a log of mod of x minus a upon x plus a plus c, and hence evaluate integral 1 upon x square minus 3 dx. This example asked in July 23 examination. Now the solution, that is here I will write here the integral instead of here x2, I will write here x square. Okay. Therefore here integral dx upon x square minus x square, that is 1 upon 2a, and the next is again, I will repeat here, change here x square, that is adjust to the numerator and the denominator 2a, that is 1 upon 2a integral 2a upon x square minus x square dx. Therefore 1 upon 2a is as it is. Now this numerator can be written as, that is a x plus a minus in bracket x minus a upon x plus a into x minus a. Now split up it, means what? X plus a upon x minus a into x plus a. Then x plus a will get cancelled. See this here? Okay. X plus a get cancelled. You will get here 1 upon x minus a minus x minus a upon x minus a into x plus a. Again x minus a will get cancelled. You will get here 1 upon x plus a. Now the integral of this 1 upon x minus a is a log of x minus a, and the integral of 1 upon x plus a is a log of mod of x plus a. And in between them is a negative sign. Therefore, there is a division. Okay. 1 upon 2a log of x minus a upon x plus a plus c. This is the answer. First answer. What about here? That is the integral 1 upon x square minus 3 dx. That is a 3 is nothing but root 3 bracket square. Therefore, the answer is I is equals to 1 upon 2a. A means what? Root 3. 1 upon 2 root 3 log of in mod of x minus root 3 upon x plus root 3 plus c. Okay. Next example. Prove that integral 1 upon a square minus x square dx is equals to 1 upon 2a log of mod of a plus x upon a minus x plus c. This example asked in March 18 and 24 examination. Again, this can be written as adjust 2a to the numerator and the denominator. Split up this, that is a minus x and a plus x. Now arrange this numerator, it's like this, that a plus x plus a minus x, and again split up this, that x plus a upon a minus x into a plus x. A plus x will get cancelled. And next a minus x will get cancelled. Then you will get here 1 upon a plus x. See this here. 1 upon 2a integral 1 upon a minus x plus 1 upon a plus x dx. Integrate this. Okay. And the integral of this is the log of mod of a minus x upon derivative of this minus x, which is minus 1 here. This is very important. Plus integral of 1 upon a plus x is a log of mod of a plus x. Therefore, you will get here log of mod of a plus x minus log of mod of a minus x plus c. Now there is a division between these two. That is 1 upon 2a log of mod of a plus x upon a minus x plus c. And this is the answer. Now next, evaluate integral 1 upon x square plus 25 dx, March 24 examination. This example asked in March 24 examination. It's simple. That integral, it is of the form integral dx upon x square plus s square. Okay. That's 25 means what? 5 square. Then you will get here 1 upon a means what? 5 tan inverse of x upon 5 plus c. This is the answer. Now next. Now we'll start the examples based on exercise 3.3. These are the examples which asked in previous year board examination, and the link of this video I will give in the description box. These are the examples which asked in board examination. I will give the link of exercise 3.3 in the description box. You must watch that video also. Okay. Now let us start here. Evaluate the integral x log of x into dx, asked in October 14 examination. Now let us start. The example based on integration by parts. Okay. Now here the first I is equals to x log of x. First we apply here the Lie rule. Okay. L-I-A-E. Okay. Now the that I is equals to x into log of x. Okay. Now what is our Lie rule? What is the first function here? The first function, the L means what? Logarithm. A means what? Algebraic. Now what is the definition of integration by parts? That is, suppose if we have the integral of the first function into second function, then what is the formula for the integration by parts? First apply with respect to Lie, arrange the order of the function with the help of the Lie. This is the first and this is the second. Here our the first function is a log of x. Okay. Second function is algebraic. Now what is the formula for the integration by parts? That is the first function into integral of the second minus integral in bracket derivative of the first function into integral of the second bracket complete into dx. Okay. Similarly here, what is our first function? F. Okay, that is the first function means what? Log of x. This is the log of x into integral of the second means what? Integral of x minus here integral whole in square bracket derivative of the first function, which is the derivative first function? Log of x, into integral of the second, which is the x, bracket complete into dx. Now simplify. It's very easy. Now what is the integral of x here? X square upon 2 integral. What is the derivative of log of x? Is 1 upon x. What is the integral of x? X square upon 2. X get cancel. You will get here x upon 2. Like that 1 upon 2 as a constant integral of the x into dx. What is the integral of x? It's x square upon 2. Then you will get here 1 upon 2 x square upon 2 plus c. Therefore, you will get here I is equals to x square upon 2 log of x minus x square upon 4 plus c. And this is the answer. First remember this. What is the formula for integration by parts? Suppose this is the first function and this is second. And what is the formula for the integration by parts? First function into integral of the second minus integral in square bracket derivative of the first function into integral of the second function bracket complete into dx. Now the next. Evaluate the integral log of x upon 1 plus log of x bracket square into dx. This example asked in October 14 examination. Let log of x is equals to t. Therefore, you will get here x is equals to e raised to t. Differentiate this. Therefore, dx is equals to e raised to t into dt. Now, substitute here. The value of dx is e raised to t into dt. Log of x is t. Log of x is t. That is the 1 plus t bracket square. That is the t upon 1 plus t bracket square into e raised to t into dt. Therefore, integral e raised to t in bracket. What is the What about the numerator? We arrange this numerator just like as the denominator. What about the denominator? It's a 1 plus t. Therefore, we'll arrange this integral e raised to t. This t can be written as t plus 1 minus 1. Where plus 1 minus 1 get cancelled, you will get here t. Therefore, integral e raised to t in square bracket t plus 1 minus 1 upon t plus 1 bracket square. Now split up this. Means what? T plus 1 upon t plus 1 bracket square. 1 t plus 1 t plus 1 will get cancelled. You will get here 1 upon t plus 1 or 1 plus t minus 1 upon t plus 1 bracket square bracket complete into dt. Now this is the of the form. Here the f of x is a f of t is a 1 upon 1 plus t and its a derivative is a minus 1 upon 1 plus t bracket square. Therefore put f of t is a 1 upon 1 plus t and its a derivative is the f dash of t is equals to minus 1 upon 1 plus t bracket square. Therefore I is equals to integral e raised to t in bracket f of t plus f dash of t bracket complete into dt. Therefore its integral is e raised to t into f of t plus c. We substitute the value of t. What about the f of t? F of t is a 1 upon 1 plus t plus c. Therefore I is equals to, what is the e raised to t means what? X. Okay. And the t means what? Log of x. Therefore I is equals to, you will get here x upon 1 plus log of x plus c. And this is the answer. Now next example. Prove that integral in root of x square minus x square dx is equals to x upon 2 x upon, I will repeat here, integral in root of x square minus a square dx is equals to x upon 2 in root of x square minus a square minus a square upon 2 log of mod of x plus in root of x square minus x square plus c. This is the important formula for the integration asked in board examination. Now proof that I is equals to integral in root of x square minus a square into 1 dx. Okay, solve this example with the help of by parts. Now here we apply here the first function as a in root of x square minus a square and the second function is 1 with the help of by parts. First function into integral of the second minus integral in square bracket derivative of the first function into integral of the second function bracket complete into dx. Now integral of 1 is x minus integral of derivative of in root of x square minus x square is what is the derivative of root of x is 1 upon 2 times root x in similar manner into derivative of x square minus x square. Derivative of x square is 0, derivative of x square is a 2x, integral of 1 is x. Here 2 will get cancelled and you will get here that x into in root of x square minus x square minus integral x into x square. Now arrange this numerator just like as the denominator. What is the denominator? That is x square minus x square. Therefore x into x square. Arrange this minus x square and plus x square. Then split up this. Okay, see this here. We will split up this. That is x into in root of x square minus x square minus integral x square minus x square upon in root of x square minus x square plus a square upon in root of x square minus x square. See this here. Okay. And then you will get here this type. What is that? X into in root of x square minus x square minus integral in root of x square minus x square dx minus a square integral of 1 upon in root of x square minus x square. What about this? This is nothing but our I. Okay. Therefore, this I is equals to x into in root of x square minus x square minus I minus a square. The integral of this is nothing but log of mod of x plus in root of x square minus x square plus c1. Okay. Now take this minus I to the left hand side. Then it will become 2I is equals to x into in root of x square minus a square log of mod of x plus in root of x square minus x square plus c1. Therefore, you will get here I is equals to 2 is multiplied here. Divide on both side by 2. Then you will get here I is equals to x upon 2 in root of x square minus a square upon 2 log of mod of x plus in root of x square minus a square plus c1 upon 2. Now replace this c1 upon 2 by c, and then you will get here the standard result. What is that standard result? Integral of in root of x square minus a square dx is equals to x upon 2 in root of x square minus a square upon 2 log of mod of x plus in root of x square minus a square plus c, and this is the answer. Okay. Now next example. Evaluate integral e raised to x in bracket in root of 1 minus x square into sine inverse of x plus 1 upon in root of 1 minus x square bracket complete into dx. This example asked in March 15 examination. Okay. Now split up this. That integral e raised to x, that is the root of 1 minus x square upon root of 1 minus x get cancelled. You will get here sine inverse of x plus 1 upon in root of sine 1 minus x square. If we substitute here sine inverse of x as f of x, its a derivative is 1 upon in root of 1 minus x square. Therefore, it is of the form integral e raised to x in bracket f of x plus f dash of x. Therefore, you will get here I is equals to integral e raised to x in bracket f of x plus f dash of x. Bracket complete into dx. Then you will get here e raised to x into f of x plus c. Resubstitute the value of f of x, which is the sine inverse of x. Okay, and this is the answer. I is equals to e raised to x into sine inverse of x plus c. Okay, this is a very simple example. Next. Evaluate integral e raised to x in bracket cos x minus sin x upon sin square x. Asked in March 18 examination. Again, here split up yes. Okay. And you will get here e raised to x. Cos x upon sin square x minus sin x upon sin square x. That is a cos x upon sin x, 1 upon sin x minus 1 sin will get cancelled. You will get here 1 upon sin x, which is nothing but cosec x. Now this is the f of x. Its a derivative is a minus. Okay. This is the f of x. Okay, take minus sign as a common. Okay, minus 1 integral e raised to x in bracket cosec x is the f of x. Its a derivative is a minus cosec x into cot x. Its integral is again that standard form. Okay, therefore I is equals to minus integral e raised to x in bracket f of x plus f dash of x, and therefore the answer is a minus e raised to x into f of x plus c. But what is f of x? F of x is a cosec x. Okay, therefore I is equals to minus e raised to x into cosec x plus c. This is the answer. Now, next example. Solve integral sec cube of 2x into dx. This example asked in July 19 examination. Okay. Now see this here. I is equals to sec cube 2x dx. Now sec cube 2x can be written as integral of sec of 2x into sec square 2x. Again by apply here the by parts. Now here what is the first function? This is the first function and this is the second function. Therefore by parts, first function into integral of the second minus integral in square bracket derivative of the first function into integral of the second function. Now solve this. Easy. Now sec of 2x, integral of the sec square 2x is a tan of 2x upon derivative of this 2x, which is a 2, minus integral. What is the derivative of sec of 2x? That is the sec of 2x into tan of 2x into derivative of 2x, which is a 2 here. It's a composite function. Okay. Now what is the integral of sec square 2x? Integral of sec square 2x is a tan of 2x upon 2. Similarly here. Okay. Now next simplification. That is the 1 upon 2. Sec 2x into tan 2x minus integral sec of 2x into tan square 2x into dx. Okay. Now again we can write this here. This is the sec of 2x. Tan square 2x means what? Sec square 2x minus 1 and the after multiplication, you will get here sec cube 2x into dx minus minus will become plus integral of sec of 2x into dx. What about this? This is nothing but I. Okay. That is 1 upon 2 sec of 2x into tan of 2x minus I plus 1 upon 2 log of mod of sec of 2x. What is the integral of sec of 2x? That is the log of mod of sec of 2x plus tan of 2x upon derivative of this 2x, which is the 2 plus c1. Okay. Now take this minus I to the left hand side, I plus I to I. You will get here 1 upon 2 sec of 2x into tan of 2x plus 1 upon 2 log of mod of sec of 2x plus tan of 2x plus c1. Okay. Then after simplification, you will get here 1 by 4 sec of 2x into tan of 2x plus 1 by 4 log of mod of sec of 2x plus tan of 2x plus c, where this c is nothing but c1 upon 2. Okay. And this is the answer. See this here, complete solution. Now next example. Now next example is that is a prove that here integral in root of x square plus s square dx. This is also very important formula. That is equals to x upon 2 in root of a square plus a square plus a square upon 2 log of mod of x plus in root of x square plus a square plus c. Okay. And here this example is also asked in board examination. We apply here the integration by parts. Similar formula we have seen in previous example. I is equals to integral in root of x square plus a square into 1 dx. Okay. Now here what is the first function here? That is in root of x square plus a square. This is the first function and 1 is the second function. That is first function into integral of the second minus integral derivative of the first into integral of the second bracket complete into dx. Now here integral of 1 is x. Now what is the derivative of in root of x square plus a square is a 1 upon 2a in root of x square plus a square. Okay. Into derivative of x square plus a square. Derivative of x square is a 0. X square is a 2x. 2 get cancelled. X into x. You will get here. That is the integral of this. 1 is x. X into x. That is x square. Now keep this first term as it is. What about the second term? X into x square. Arrange this numerator just like as the denominator. Means what? X square plus a square minus a square. Means what? Arrange, add plus a square and minus a square. Then split up this. See this here. First term is as it is. Okay. Minus integral x square plus a square upon in root of x square plus a square minus a square upon in root of x square plus a square dx. Okay. Now what about the power of this? The power of this is that is the 1. Means what? X square plus a square is to 1. And here the power of this is x square plus a square is 1 upon 2. After simplification, you will get here in root of x square plus a square, and which is nothing but this side. Okay. See this here. Okay. So the part. Okay. Now this here. That is x into in root of x square plus a square minus integral x square plus a square upon in root of x square plus a square minus a square upon in root of x square plus a square dx. Okay. And the this is the I. And what about the integral of dx upon in root of x square plus a square is nothing but log of in mod of x square plus in root of x square plus a square plus c1. This minus I. Take this minus, shift this minus I to the left hand side. It will become plus I plus I to I. Therefore 2I is equals to x in root of x square plus a square log of mod of x plus in root of x square plus a square plus c1. Okay. Therefore I is equals to x upon 2 in root of x square plus a square upon 2 log of mod of x plus in root of x square plus a square mod complete plus c by 2. Now replace this c1 by 2 as a c. Okay. And therefore this is the formula for the integral of in root of x square plus x square dx is equals to x upon 2 in root of x square plus x square plus a square upon 2 log of mod of x plus in root of x square plus a square plus c, where c is equals to c1 upon 2. And here the c1. Okay. And this also here first. And then this. Now, next example. Let us prove that here. Integral in root of a square minus x square dx is equals to x upon 2 in root of a square minus x square plus a square upon 2 sine inverse of x upon a plus c. This example asked in also board examination 96, 2002, 16 and the 22, July 22 examination. Again here we solve this example with the help of the integration by parts. What's the first function here? In root of a square minus x square. Second function is a 1 here. Therefore, by parts, first function into integral of the second minus integral derivative of the first into integral of the second bracket complete into dx. Therefore, in root of a square minus x square, integral of 1 is x minus derivative of in root of a square minus x square is a 1 upon, that is a 2 in root of a square minus x square, derivative of x minus x square is a minus 2x. Integral of 1 is a x into x square, 2 will get cancelled. Again arrange this numerator in the form of the denominator, the minus integral a square minus x square minus x square. Then split up this. You will get again I will be repeated there. Write the first term as it is minus integral in bracket a square minus x square upon in root of a square minus x square minus a square upon in root of a square minus x square bracket complete into dx. Okay. Now next is a again this a square minus a square has a power 1 and this has the root. Then 1 power half power will be get cancelled. Then you will get your integral in root of a square minus x square dx. This minus and minus that will be plus a square integral of 1 upon in root of a square minus a square. And this very simple integration, that is a sine inverse of x upon a. Okay. Then this is the minus I, shift this minus I to the left hand side. It will become I plus I to I. To I is equals to x in root of a square minus x square plus a square sine inverse of x upon a plus c1. Then divide on both sides by 2. Then you will get your I is equals to x upon 2 in root of a square minus x square plus a square upon 2 sine inverse of x upon a plus c1 upon 2. The value of c1 upon 2 is nothing but c, and this is the integration of in root of a square minus x square dx. Okay. Now next example, and see this also. The first part, this is the first part and this is the second part. Now next, evaluate integral e raised to sine inverse of x in bracket x plus in root of 1 minus x square upon in root of 1 minus x square into dx. This example asked in July 22 examination. Okay. Let I is equals to integral e raised to sine inverse of x in bracket x plus in root of 1 minus x square upon in root of 1 minus x square dx. Now put here sine inverse of x as t. Therefore x is equals to sine t. Its a derivative is dx is equals to, or the derivative of sine inverse of x is the 1 upon in root of 1 minus x square dx is equals to dt. Okay. Therefore our integral become, that is in integral e raised to t, the value of first is a sine t plus, okay, in root of 1 minus sine square t. Okay. Therefore here the dx upon in root of 1 minus x square is nothing but dt. The value of x is a sin t, and in root of 1 minus sin square t, which is nothing but the cos t. Therefore, again, this is the standard result. This is the f of x, and the derivative of f of x is the means what sin of derivative of sin of x is the cos of x. F of x plus f dash of x. This is standard formula. That I put f of t is a sin t, f dash of t is a cos t, and hence here the result here. This is the previous one. Therefore, here the e raised to t here, e raised to t in bracket f of t plus f dash of t bracket completely into dt. Its integral is e raised to t into f of t plus c. Okay. Resubstitute the value of f of t, which is sin t, and finally also the value of t, which is the sin inverse of, this is sin inverse of x into x plus c, and this is the answer. That is I is equals to e raised to sin inverse of x into x plus c. Now next example, evaluate integral x into tan inverse of x into dx. This example asked in March 23 examination. Now the solution, I is equals to x into tan inverse of x. Okay. Now again we'll solve this example with the help of the integration by parts. First liate. Okay. Now here the L I A T E. What is your function? That is inverse, and the algebraic first is inverse, then the algebraic. Okay. That is the integral of tan inverse of x into dx. That is the tan inverse of x first function into integral of the second minus integral derivative of the first into integral of the second. Now the integral of x is x square upon 2. Derivative of tan inverse of x is 1 upon 1 plus x square. The integral of x is x square upon 2. Okay. See this here. This is the first part. That is a 1 upon 2 x square tan inverse of x minus 1 upon 2 integral x square upon 1 plus x square into dx. Now arrange this numerator just like as the denominator. Means what? 1 plus x square minus 1. Arrange plus 1 and the minus 1. Then split up this. 1 upon 2 x square tan inverse of x minus 1 upon 2 integral 1 plus x square upon 1 plus x square. You will get here 1 minus 1 upon 1 plus x square bracket complete into dx. That is 1 upon 2 x square tan inverse of x minus 1 upon 2 integral of 1 is x. Integral of 1 upon 1 plus x square is a tan inverse of x plus c. And normal simplification. That is I is equals to 1 upon 2 x square tan inverse of x minus 1 upon 2 x. Minus minus will become plus 1 upon 2 tan inverse of x plus c. Okay. Now next. If u and v are two functions of x, then prove that. It's a very important theory bit. And always asked in board examination that the integral of u into v into dx is equals to, this is the formula for the integration by parts, u into integral of the v minus integral derivative of the u into integral of the v. Okay. This example asking, this theory bit question asking number of examination. Therefore, this is very, very, very important. And hence evaluate integral x into e raised to x into dx asked in July 16 examination. And also it is given in the textbook also. Now to solve this here. Also evaluate, that is a integral of, here is a, we'll write here, integral of log of x into dx. Okay. It is here proof. Let, what is your assumption? That is the let integral of v dx is a w. Therefore, the derivative of w is a v. Okay. Now consider ddx of u dot w. Apply the product rule. U into derivative of the w plus w into derivative of the u. Next, ddx of u dot w is equals to, first, what is the derivative of w? Is v. Next, du by dx. But what is the w? W is nothing but integral of v. Substituting the values, these values. Okay. Now, it's very simple and easy step here. Integrating on both sides. Then what you will get here? Integrating on both sides, this derivative and integration will get cancelled. You will get here u dot w and integral of this and integral of this. That integral of uv dx plus integral of this whole term. Therefore, we take here bracket. That is integral of in bracket du by dx integral of v dx bracket complete into dx. Okay. And therefore, this can be again written as, but what about the w? This w is nothing but integral of v dx. Okay. And hence here, this can be written as, that is it. We want to find out this integral of u into v dx. This is our main. Now shift this term to the left hand side. It will become minus here. Therefore, integral of u v dx is equals to v into integral of u into integral of v dx minus, if we shift this term to the left hand side, it will become minus integral of du by dx integral of v dx into dx. And this is the important theory bit. Okay. For the integration by parts. Okay. Now we'll solve this example with the help of the integration by parts. That integral of x into e raised to x dx. Now here are the two functions. First is algebraic, second is the exponential. If you apply here the Layet rule, what is the real rule? L-I-A-T-E. That is here are the two functions, algebraic. The first is algebraic and last is exponential. Therefore, our first function is algebraic and second is exponential. Therefore, first function into integral of the second minus integral derivative of the first into integral of the second bracket complete into dx. Integrate it. Very simple integration. What's the integral of e raised to x into e raised to x? Derivative of x is 1, 1 into e raised to x dx. Integral of e raised to x is again e raised to x. Take e raised to x as a common. Then you will get here simplified integration. I is equals to e raised to x in bracket x minus 1 plus c. Okay. Now, next. That I is equals to integral of log of x into dx. Now, here we generate here one more term, that is a 1 into dx. Again here apply the Layet rule, L-I-A-T-E. That is logarithm and then the algebraic. Here the first function is a logarithm, second is a algebraic. Therefore again by parts, first function into integral of the second minus integral in square bracket derivative of the first function into integral of the second. Integral of 1 is x. Derivative of log of x is 1 upon x. Integral of 1 is x. X has it cancelled. Then x into log of x minus integral of dx. Integral of dx is 1 dx is x. Hence, you will get here the answer. I is equals to x log of x minus x plus c. This is the answer. Okay. Now, next. I will repeat here again. These all examples are based on exercise 3.4, which asks in board examination. And I will give the link of exercise 3.4 of the textbook in description box. You must watch that video also. Here the first example. Evaluate integral 1 upon x in bracket x minus 1 dx. Okay. Now here the that I is equals to integral 1 upon x into x minus 1 dx. Now arrange this like this. That is 1 upon x into x minus 1 is equals to a upon x plus b upon x minus 1. After simplification, you will get here 1. That is multiplied on both sides by x into x minus 1. Then you will get here 1 is equals to a in bracket x minus 1 plus bx. This is the first one. Now find the value of a and b. First put x is equals to 0, then you will get your value of a. Then put x is equals to 1, then you will get your value of b. If you substitute x is equals to 1, then you will get your value of b. B is equals to 1. Now next put x is equals to 1 in this equation. Okay, x is equals to 0. If you substitute the value of x is equals to 0, then you will get your value of a. That is 1 is equals to a into minus 1. Here I have repeated here again. Therefore a is equals to minus 1. Okay, the value of a is minus 1 here. And the value of b is 1. Therefore 1 upon x in bracket x minus 1 is equals to minus 1 upon x plus 1 upon x minus 1. Very simple integration, integrating on both sides. That the integral of minus 1 upon x is a minus log of x, and the integral of 1 upon x minus 1 is a log of mod of x minus 1. Okay. You can arrange it like this also. That is the log of mod of x minus 1 minus log of mod of x plus c. Therefore, I is equals to log of mod of x minus 1 upon x plus c. And this is the answer. Next, evaluate x square upon integral x square upon x square plus 2 into in next bracket 2x square plus 1. This example asked in March 14 examination. Okay. Now here can arrange this term like this. That x square upon in bracket x square plus 2 into x 2x square plus 1 upon a upon x square plus 2 plus b upon 2x square plus 1. Now multiply on both sides by in bracket x square plus 2 into in bracket a 2x square plus 1. Then you will get here x square is equals to a in bracket 2x square plus 1 plus b in bracket x square plus 2. Now find the value of a and b. That is putting x square is equals to minus 2. Then you will get your value of a. Okay. That is minus 2 is equals to a in bracket 2 into minus 2 plus 1. Therefore minus 2 is equals to minus 3. A is equals to 2 by 3. Okay. That is next put x is equals to x square is equals to minus 1 upon 2 in 1. Then you will get the value of b. That is minus 1 upon 2 is equals to b in bracket minus 1 upon 2 plus 2. Okay. Therefore, you will get here the value of b. That is equals to minus 1 upon 2 into 2 by 3, which is equals to minus 1 by 3. These are the values of a and b. Now our integration is very simple now. Integrating on both sides. This is the I. Okay. I is equals to 2 by 3. Integral of 1 upon x square plus 2 dx minus 1 by 3. Integral of 1 upon 2x square plus 1 dx. Okay. 2 means what? Root 2 square. Take 2 as a common. Then 1 upon 3 into 2. That is 1 by 6. Integral of 1 upon x square plus 1 upon root 2 bracket square dx. The integration is easy. Okay. This is of the form tan inverse. That is 1 upon a. A means what? Root 2. Tan inverse of x upon root 2 minus 1 by 6. 1 upon root 2 tan inverse of x upon 1 upon root 2 plus c. After simplification, you will get here 2 upon 3 root 2 tan inverse of x upon root 2 minus. Now, you will get here root 2 upon 6 tan inverse of x root 2 plus c. And this is the answer. Okay. 2 upon root 2 means what? This 2 means what? Root 2 into root 2. 1 root 2 will get cancelled. Then you will get your I is equals to root 2 upon 3 tan inverse of x upon root 2 minus 1 upon 3 root 2 tan inverse of root 2 x plus c. Now next, evaluate integral 1 plus log x upon x in bracket 2 plus log x into next bracket 2 plus log x. Asked in March 16 examination. Okay. Now here the substitution 1 plus log of x is t. 1 upon x dx is equals to dt. Therefore your integral I is equals to integral t into dt. That is 1 plus log x means what? T into dt. Dx upon x is replaced by dt. Therefore I is equals to integral t into dt in bracket 1 plus t into 2 plus t. Next, find the partial fraction. T upon in bracket 1 plus t into 2 plus t. A upon 1 plus t plus b upon 2 plus t. And multiply on both sides by 1 plus t into 2 plus t. Then you will get a t is equals to a in bracket 2 plus t plus b in bracket 1 plus t. Okay, now find the value of a and b. Put t is equals to minus 1, you will get your value of a. That is minus 1 is equals to a in bracket 2 minus 1. A is equals to minus 1. Next, putting t is equals to minus 2, then you will get your value of b. Okay, that is minus 2 is equals to b in bracket 1 minus 2. B is equals to 2. Therefore, our integral, okay, this integration can be written as it's like this. Okay, this is the t here, t. Okay, that is I is equals to integral minus 1 upon 1 plus t dt plus 2 upon 2 plus t dt. Its integration is a minus log of mod of 1 plus t plus 2 log of mod of 2 plus t plus c. Okay. Next, replace the value of t, which is the 1 plus log of x. Therefore, you will get here that is a minus log of 1 plus log of x plus 2 log of 2 plus 1 plus log of x plus c. That is 1 plus 1 is a 2 log of mod of 2 plus log x plus 2 log of mod of 3 plus log x plus c. Therefore, the answer I is equals to, that is a 2 into log of 3 plus log x means what? Log of mod of 3 plus log x bracket square minus log of 2 plus log x plus c. Next example, evaluate integral x plus 1 upon x plus 2 into x plus 3 dx. Asked in July 16 examination. Solution I is equals to, okay, again by partial fraction. X plus 1 upon x plus 2 into x plus 3 is equals to a upon x plus 2 plus b upon x plus 3. After simplification, that is the multiplying on both sides by x plus 2 into x plus 3, you will get x plus 1 is equals to a into x plus 3 plus b into x plus 2. Find the value of a and b. Put x is equals to minus 3, you will get your value of b. That is minus 3 plus 1 plus this a will become 0. Plus 3 minus 3 will get cancelled. That is a b in bracket minus 3 plus 2. Therefore, b is equals to, this minus b is equals to minus 2, b is equals to 2. Putting x is equals to minus 2, then you will get your value of a. Minus 2 plus 1 is equals to a in bracket minus 2 plus 3. Therefore, a is equals to minus 1. Okay, therefore here again the simplification, simple integration. Okay, we will arrange this here, integral 2 upon x plus 3 minus 1 upon x plus 2. Integral is of the form log form, that is the 2 log of mod of x plus 2 minus log of mod of x plus 2 times log of mod of x plus 3 minus log of mod of x plus 2 plus c. Okay, this becomes square, that is the log of mod of x plus 3 bracket square minus log of mod of x plus 2 plus c, and I is equals to log of mod of x plus 3 bracket square upon x plus 2 plus c, and this is the answer. Okay. Now, next example. Evaluate the integral d theta upon sine theta plus sine of 2 times theta. This example asked in March 17 examination. Now, again here, the sine of 2 times theta means what? 2 sine theta into cos theta. Take sine theta as a common. Okay. Then multiply numerator and denominator by sine theta. Then what you will get here? Sine theta into d theta. Sine theta into sine theta means what? Sine square theta. In bracket 1 plus 2 cos theta. Okay. But what is the sine square theta? Sin square theta means what? 1 minus cos square theta. Okay. Now again 1 minus cos square theta means what? 1 minus cos theta into 1 plus cos theta into again 1 plus 2 times cos theta. Put here, that is the cos of theta is equals to t. And then solve this by method of substitution. That is the cos of theta is equals to t minus sin theta into d theta is equals to dt. Therefore, you will get here sin theta into d theta is equals to minus dt. Therefore, I is equals to minus dt upon 1 minus t into 1 plus t into 1 plus 2t. Take the minus sign outside this integration. You will get your integral dt upon 1 minus t into 1 plus t into 1 plus 2t. Then by the partial fraction, find the value of a, b, c. Multiply the whole term by on the both side by 1 minus t into 1 plus t into 1 plus 2t. Then you will get here 1 a in bracket 1 plus t 1 minus 2 1 plus 2t b into 1 minus t into 1 plus 2t plus c 1 minus t into 1 plus t. Find the value of a, b, c. Put t is equals to 1, then you will get your value of a. Okay. Similarly, here the a is 1 by 6. Putting the value of t is equals to minus 1, then you will get the value of b minus 1 by 2. And the last, put t is equals to minus 1 upon 2. Then you will get the value of c. A and b will become 0. The value of c is 4 by 3. It's very simple calculation. These are the value of a, b, c. Now, this is very important. Therefore, now integrating on both sides, that I is equals to minus integral in square bracket 1 by 6 upon 1 minus t. The value of b minus 1 upon 2 upon 1 plus t plus value of c 4 by 3 upon 1 plus 2t. Integrate this. Minus 1 by 6 integral 1 upon 1 minus t dt plus 1 upon 2 integral 1 upon 1 plus t dt minus 4 by 3 integral of 1 upon 1 plus 2t dt. That is minus 1 by 6 log of mod of 1 minus t upon minus 1 plus 1 upon 2 log of mod of 1 plus t minus 4 by 3 log of mod of 1 plus 2t upon 2, because the derivative of 2t is a 2 here plus c. Okay. Now next substitute the value of t, which is the cos t. Okay. That is this is the last term, which is the minus 2 upon 3 log of mod of 1 plus 2 cos of theta, okay, plus c. Okay. And after simplification, therefore this is the answer. Okay. Now next example, evaluate integral 8 upon in bracket x plus 2 into x square plus 4 dx. This example asked in July 17 examination. Now this type is also very important. Now the solution. I is equals to integral 8 upon in bracket x plus 2 into x square plus 4. This type is very important. That is 8 upon x plus 2 into x square plus 4, a upon x plus 2 plus bx plus c upon x plus 4. Okay. Now after the simplification, that is the multiplying on both sides by x plus 2 into x square plus 4. Then you will get here 8 is equals to a in bracket x plus 4 plus bx plus c into x plus 2. Okay. This is the first one. Put x is equals to minus 2. You will get here value of a. Okay. A is equals to 1. Put x is equals to 0. Then you will get here the form is like this. 8 is equals to 4a plus 2c. And after simplification, substituting the value of a, that is the 1. Then you will get the value of C, which is equals to 2. Now we find the value of B. Okay, for the value of B, put here x is equals to 1. Then you will get here the equation in terms of A, B, C. But we know the value of A and C. And with the help of this, you can find the value of B. This is the one way to find the value of remaining value. Therefore, B is equals to minus 1. Substitute the values of A, B, C. That is A means what 1. 1 upon x plus 2 plus B is minus 1 means what minus x plus 2. Okay, C is equals to 2. Now this is the form. This is very important. Therefore, here the integration separate can be written as integral of 1 upon x plus 2 dx minus integral of x upon x square plus 2 dx plus integral of 2 upon x square plus 4. Separate here, split up here. Okay. Now what about here? This is the log form. Now arrange this numerator. It's like this. 2x. Okay. But that is a multiplied and divided by 2 for the numerator and the denominator. That is 1 upon 2. And arrange here 2. That is a 2 to the numerator and 2 to the denominator. That is a minus 1 upon 2 integral 2x upon x square plus 4 dx plus 2 integral of this 2. Take outside this integration 1 upon x square plus 2 square dx. Therefore, its integration is a log of mod of x plus 2 minus 1 upon 2 log of mod of x square plus 4 plus 2 into 1 upon 2 tan inverse of x upon 2 plus c. Okay. And then after simplification, you will get here I is equals to log of mod of x plus 2 minus 1 upon 2 log of mod of x square plus 4 plus tan inverse of x upon 2 plus c. This is the answer. Now next, example number 7. That integral e raised to x upon in bracket 1 plus e raised to x into 2 plus e raised to x dx asked in July 18 examination. Now see this here, the solution I is equals to integral e raised to x upon in bracket 1 plus e raised to x into in bracket 2 plus e raised to x dx. Now put here e raised to x as a t. E raised to x into dx is dt. Therefore integral become I is equals to integral dt upon in bracket 1 plus t 2 plus t. Now by with the help of the partial fraction 1 upon in bracket 1 plus t into 2 plus t is equals to a upon 1 plus t plus b upon 2 plus t. After simplification, that is multiplied on both sides by 1 plus t into 2 plus t, then you will get here 1 is equals to, okay, this is the 1. 1 is equals to a into in bracket 2 plus t plus b in bracket 1 plus t. This is the first one. Find the value of a and b. Put t is equals to minus 1 and minus 2. You will get the value of a and b. First put t is equals to minus 1. You will get your value of a. Put t is equals to minus 2. You will get your value of b. Now here a is equals to 1, b is equals to minus 1. And substitute here. These are the values. This is the second part. I is equals to integral. The value of a is 1, b is minus 1. Integration of this is very simple. That is the log of mod of 1 plus t minus log of mod of 2 plus t plus c. Resubstitute the value of t, which is e raised to x. Now this is the log of m minus log of n means what log of m upon n. Therefore I is equals to log of mod of 1 plus e raised to x upon 2 plus e raised to x plus c. And this is the answer. Okay. Now next example. Evaluate integral 2x square minus 3 upon x square minus 5 into x square plus 4 into dx. Asked in March 23 examination. Okay. Now here solution. Now we have solved this type of examination. Example by the partial fraction multiplying on both sides by bracket x square minus 5 into x square plus 4. Then you will get here 2x square minus 3 is equals to a in bracket x square plus 4 plus b in bracket x square minus 5. This is the first one. Putting x is equals to 5. you will get your value of a. Okay, see this here, b will become 0. 2 into 5 minus 3 is equals to a in bracket 5 plus 4. Therefore, 7 is equals to 9, a is equals to 7 upon 9. Put x square is equals to minus 4. You will get your value of b. That is the 2 into minus 4 is minus 4 minus 3 is equals to a into 0 plus b into in bracket minus 4 minus 5. Okay. And hence you will get your value of b is 11 upon 9. Okay. Therefore, here I is equals to integral 7 upon 9 x square minus 5 plus 11 upon 9 x square plus 5 bracket complete into dx. Now separate the integral. Take the constant outside the integration. 5 means what? Root of 5 bracket square. 4 means what? 2 square. It's of the form x square minus x square means what? 1 upon 2a. 7 by 9 into 1 upon 2a. A means what? Root 5. Log of x minus a upon x plus x minus root 5 upon x plus root 5 plus 11 upon 9 1 upon 2. This is of the form tan inverse. That is integral dx upon x square plus x square 1 upon a tan inverse of x upon 2 plus c. Then after simplification you will get here 7 upon 18 root 5 log of mod of x minus root 5 upon x plus root 5 plus 11 upon 80 tan inverse of x upon 2 plus c. And this is the answer. Okay. Now next example. Evaluate integral 5 e raised to x upon e raised to x plus 1 into e raised to 2x plus 9 dx asked in March 24 examination. Now here the substitution, that is the e raised to x is t, e raised to x into dx is equals to dt. Therefore I is equals to integral 5t upon t plus 1 in first bracket, second bracket t square plus 9. Now this can be written as a upon t plus 1. Note this. Okay. bt plus c upon t square plus 9. We have solved this type of example. Now after simplification, that is multiplying on both sides by t plus 1 into t square plus 9. Then you will get here 5u is equals to a in bracket t square plus 9 plus bt plus c in bracket t plus 1. Okay. This is the first one. Now find the value of a, b, c. First put t is equals to minus 1. You will get the value of a. Okay. See this here. A is equals to 1 upon 2. Put t is equals to 0. Then you will get the value of c is 1 upon 2. Put the value of t is equals to 1 in equation 1. Then you will get here the terms in terms of a, b, c. And here substitute the value of a and c. You will get here value of b minus 1 upon 2. And hence our integration is written as in this fashion. Okay. And finally see this here. This is the big one. Therefore we require here 3 slides integrating on both sides. Okay. This is of the log form. First one is take 1 upon 2 as a common. Next integral of this, that is 1 upon t plus 1 dt minus t upon t square plus 9 dt plus 1 upon t square plus 9. This integration is easy. This is a log form. Arrange here multiplied numerator and divided by 2. Then you will get to 2t upon 1 upon 2. Okay, it's of the log form. And this is the tan inverse form. Therefore, this is the log. Okay, by arranging numerator and denominator by 2, and this is the 1 upon a tan inverse of t upon 3 plus c. Resubstitute the value of t here. And hence this is the answer. And In this way, we have completed all topics of indefinite integration. I will give the link of all the videos of this chapter in the description box. You see all these videos and so that you will get more marks in the examination. Now we will see in the next video. Till then, goodbye.